So welcome to our second talk here on the Kakadu Bar stage. For the second talk, we have Max Vorhauer with us. He's product manager at Mataonu. And he describes himself as a walking toolbox. So it seems he has a lot of knowledge about different kinds of methods, all related to digital products. And he also describes himself as being always very positive. From what I can see from your bright smile always, I think that's obvious. And something interesting to know, Max can still name all of the 150 Pokemons. So we check this later. Okay, so your talk today is about using AI for the perfect pitch, and this is your stage.
Thanks very much, Paula. Let me correct this, of the first generation. Only the first generation.
First generation, yes.
Pokemon. So, but we'll check this later at the after-show party. Yes. Yeah. Hi everybody, how's everyone doing? How are the people over there in the lounges? Nice, comfortable situation down here. It's pretty cool. Yeah, as Paula said, I'm Max, and I'm here to entertain you for the next 30 minutes or so. 2018 was the first and only time I visited the DecompileD conference, and it was an awesome experience. It was the first time I ever visited a tech conference, and I met so many cool people. I see a few faces in here, and yeah, I just thought this year I want to take the opportunity and give something back to the community. And yeah, before I get emotional here, I just start with my talk. This is the situation we are currently living in. Each company is doing Zoom talks, universities, schools are adopting to it. Heck, we even started doing parties and drinking games over Zoom. But Zoom fatigue is slowly creeping in. Who of you feels this Zoom fatigue jumping from one call to another? Show of hands. Yeah, quite a few. There are actually some good tips on how to handle this. But that's not the topic of my talk, but we can talk about this later. I want to actually focus on the emotion shown in this Zoom room. Most, or two people, look like they would rather eat licorice than be present in this virtual room. And two even don't have turned the camera on. It's maybe good for casual dress code, but for the speaker or for the referent, it's not the perfect opportunity. And if your job depends on reading the room, so to speak, it's even harder. Market researchers need to understand what kind of emotions are present, not only the very obvious ones, but also the nuances. Take video testing, for example. I show you a scene of Titanic, and I want to know exactly how you feel. I don't only want to see, oh, you're sad or you're happy. No, I want to see in which scene exactly do you express the sad emotion, so I know how to optimize my movie, how to optimize my advertisement. And this is the reality market researchers are living in. They're trying to use Zoom to get exactly this feedback, which prior to COVID, they could get from equipment like ECGs or something. So that's why we at Mataonu developed an emotion analyzer that takes micro expressions in your face, puts it to emotion, and then you can use it to get feedback from such situations like movies or even meetings. I could talk about a lot of things today, but I don't want to have a sales pitch here. I would rather share a few lessons learned we encountered in 1.5 years of developing our algorithm. Let me quickly follow up on the introduction earlier, why I am here a product manager and not one of our programmers. Short answer is probably I'm one of the extroverts at our company, and so of course I volunteered to jump on stage to present our findings. Also I have quite some background in machine learning and AI. At Mataonu we work on this idea for 5 years already, so I can also share not only technical details, but some insights we gained from projects we did in the past. Before we get to the technical stuff, let me quickly get you up to speed on emotions. Emotions are basically what happens in your brain when some reaction triggers chemical movements. Hormones are produced like crazy or retracted based on the feeling, and then you get into this mental state of the emotion, for instance, sadness, when you see Titanic. Now you can express emotions in different kind of types. And the theory underlying this is that emotions are discrete, measurable, and distinct. So you can really specify which emotion is shown. The first research discovered 6 basic emotions: happiness, sadness, fear, disgust, anger, and surprise. And later researchers added 50 more, but I think there are also more derivations of these basic emotions. As I said earlier, you have multiple kinds of expressing emotions. For instance, vocal expressions, what you say and how you say it. I will start talking really, really fast because I'm excited to standing here in front of you. Or I could just talk slowly to you. And then, of course, how I say it. It is a stupendous experience to stand in front of you, rather than just nice. Then you have the bodily symptoms. Your heart starts pounding, you start sweating, you get goosebumps on your arm. These are all symptoms that show that your body expresses emotions. Researchers still use a lot of equipment today to get these kind of reactions. But of course, I want to focus on facial expressions. All the micro-expressions you show involuntarily and subconsciously. It takes you around 20 milliseconds to produce a smile or a frown. And let me show you in a moment how we can get emotions from these micro-expressions. But first I want to introduce the mastermind of emotion analysis. Paul Ekman researched emotions since the 50s. He uncovered universal micro-expressions that are present in every human on Earth in the 60s and codified it in the facial action coding system in 1978. This is the basis for our algorithm. You might know his work from pop culture. Paul Ekman was a scientific advisor for the TV show Lie to Me, where he actually applied the facial coding for lie detection. And he was an advisor for the Pixar movie Inside Out, which personifies these basic emotions. And his underlying theory says that there are action units in your face, certain micro-expressions all over your face that determine an emotion. And in combination, they make up happiness, sadness, and so forth. For instance, I'm not sure whether you can actually read this, but there's one micro-expression, it is a cheek raiser, and then you combine it with a lip puller, now both. And this is happiness. It's more natural if you don't use your face but your actual facial muscles, but I think you see what I mean. So with all these little micro-expressions or action units, there are around 44, and these make up the emotions we measure with our algorithm. Alright, let's dive into the technical stuff a bit and uncover some lessons learned. So of course, you need the video stream to actually analyze a face or a video. We mostly use Zoom for it, and actually Zoom is making our life a little bit harder because it's hard to get real-life data from the video streams. So we need to just get the data or fetch the data afterwards, but for market research use cases, it's kind of okay because they always work in retrospective. And we get the video and then we split it into its individual single frames and put it through our algorithm. The first step is a neural network detecting the face in the actual frame. We use here the VGG face developed by Oxford researchers because it's just the best out there. It's trained on millions of data and it detects faces like crazy. And this is the first lesson learned. AI gets increasingly commoditized. You can easily find models online, publicly available, or buy them for less than it would take your engineers to actually come up with something by themselves. And face detection, speech transcription are all the stuff you can buy and don't have to develop yourself. So always keep a lookout for things that make your life easier. Afterwards, we try to get all the landmarks in your face, all this not really micro expressions first, but first landmarks that determine if you're looking frontally into the camera, because some action units only make sense if you know you're looking at the front of the face, like this lip puller. You need to know that both muscles are working, otherwise you don't get the happiness emotion from it. Then an interlude is the re-recognition of people that already looked in the camera, because as a researcher, you don't want to mix and match emotions of people. You need to exactly identify which people has shown which emotion in which timestamp. So we have, basically a similarity check at this stage. And then in the end, the neural network to detect the actual action units and then combine them to have a confidence level about the emotion. And then the emotion or the most dominant emotion that passes an internal threshold with its confidence level is the one we use. Everything below is discarded. We use this data input for our fancy formula. We came up with a lot of trial and error, and also with the help of a psychologist. It's like a weighted emotion score where each emotion is evaluated a little bit differently. And then in the end, we use this emotion score to show it in a diagram. As you see on the right-hand side, it's emotion over time. And we try to use some moving average, so it doesn't look like this, very erratic, but rather smoothly. And this gives all the indication how the meeting went, what went wrong, where there's slides that didn't quite work well. And without being present at the meeting, we can tell a lot about its success afterwards. Yeah, so overall this looks pretty obvious, pretty straightforward, and after 1.5 years I would say, yes, that was the best way to do it. And of course there are a few challenges we encountered during our process. And one very important one was processing speed. I told you earlier we don't need real-time analysis for our target group, but actually we had some meetings earlier where we had a 30-minute meeting and our algorithm took 300 minutes to analyze it. That's 10 times the original length. And this is not viable if you need to analyze 15 interviews for market researchers in 1 week. So we needed to improve our algorithm on this. And let's have a look at an actual Zoom meeting. You see this 25 faces here is 1 second because Zoom records with 25 frames per second. And when you look exactly on each face, you don't see much difference because each face represents like 40 milliseconds. I earlier told you it only takes you 20 milliseconds to produce a smile, but researchers actually claim that emotions last until 90 seconds. It's quite a lot. In our project, we discovered they change a bit more quicker, but it totally makes sense to only use part of these frames and not all of them. So that's why we just introduced the frame skip. For Zoom meetings, we only use a fifth of the available frames for each second. And when you still look at the highlighted images and the highlighted faces, you see this is quite enough to get the emotion of this exact second. So the lesson learned here is that you need to think about how much data you need. Sometimes we are in this mood where we say, oh, we need as much data as possible, we need to crunch as much data as possible, but then in real life application, it slows you down. So we said, okay, we're missing out on 4/5 of the available data points for us, but it still gets us the result, and more importantly, our customers get their result. But we wanted to get even faster, and we looked at another part of our algorithm, and this is the recognition part. So what we basically do is that we save a descriptor image for each person that looked into our camera. And then every time we encounter a new frame, we compare the newly found descriptor image with the old ones. And we use a cosine similarity for this, and if the score is below a certain threshold, then we declare two faces as similar. This helps us to merge the people or the faces that look into the camera for all or along the meeting. Sometimes it's pretty hard. As you see here, it's kind of okay. I just twisted my head a bit, but sometimes when people like put their hands in front of their faces, the camera or our algorithm gets a little bit confused. And if we can't match them with our cosine similarity, we kindly ask the user afterwards to do like a manual merge. And this manual merge is like saying, hey, this descriptor image matches this descriptor image and this one. So in the end, we get like 100% of the people in the room. So our original approach for this is that we save a set of descriptor images for each face we identified, and it's a set of 10 images. Now you have two approaches when you have this set of 10 images. First, you can start comparing your newly found descriptor image with the first item of your set. That might be from the beginning of the meeting, so they might diverge a bit, and you don't get this perfect match. Or you compare your descriptor image with the last item of your set. Then, in best case, you have an image that is maybe 1 second ago or just a couple of seconds ago, so it's easier to spot the match. And for performance considerations, we thought, okay, when you start at the front and the first one is really, really early in the meeting and now you're very late in the meeting, there's a big time difference and there might be some big differences in where your face are, how the lighting is, and so you would need to go through all the items in your set and do the calculation multiple times. And then when we go from the back, on the other hand, we do this operation much less because the last image is probably just a few minutes ago. In hindsight, this kind of makes a lot of sense, but bad news here, it didn't improve our performance. The cosine similarity operation is so fast, it doesn't matter if you run through your set 1 time or multiple times, or if you do it once or 9 times. So no performance improvements, unfortunately, but we improved another very important indicator, the user experience. This manual merges I told you earlier, when after the meeting the user needs to compare the faces. We couldn't quite connect with each other. He or she needs to do this all by herself, himself, and if you have a lot of these mismatches, it can take quite a time. But with our approach, starting from the back rather than starting from the front, we reduced this manual merges by 60%. And that is even better than performance improvement because now the user has to do less clicks, a better user experience, and is happier and more satisfied with the application. Another important factor when trying to improve this recognition algorithm is the threshold. You see here 2 models we tried out, and you see when you set the threshold to a certain point, then it might recognize the faces you want, or it recognizes different faces as one. So this is quite bad, so you need to really find the Goldilocks spot for this threshold. Another hurdle we came across next to speed was memory consumption. You see here an abstract diagram of the memory of our working memory, and you see there was a regular spike when we had an asynchronous job that was triggered the exact same minute every hour. And our application is the green color, and then when this asynchronous job started, our working memory was at its full capacity, and these out-of-memory killers started to stop our emotion analyzers. And so we had this case where we had I think 700 megabyte video, and we wondered, why does the analyzer stop all the time? Why do we need to re-trigger it? And this was the reason after some digging. So one lesson learned here is don't sync all your asynchronous times, so don't schedule them at the exact same minute. Try to spread them over the hour. You still have 60 minutes where you can spread them, so try to do this. And talking about the memory problem, how did we solve this? Unfortunately, the simple answer is just more resources. We inspected our code, we didn't find any linkage, there were no obvious inefficiencies. It was just that the framework we used for the neural networks took its memory space, and when we work each frame, they take their memory spaces. So it's nothing we could do rather than resources. And of course, as a perfectionist, we tell ourselves, that is not the ideal solution because you really want to be smart and you really want to figure it out. But especially when you're early in the product, you need to make trade-offs. You have only limited resources, limited time, and then use rather resources that are cheaper than your engineering power, so your engineers can turn to the really complex problems that matter. A few words about benchmarking. The earlier you do it, the better. We didn't do benchmarking from the beginning, and we still only do some benchmarking in a manual process, but especially at first, it was like working on a black box. Each improvement we tried was guesswork, so we spent a lot of time just poking in the dark. So the earlier you introduce parameters you track, like performance, like manual merges, the better you can really track the improvements you made over time. Bonus points if you introduce it in your CE pipeline, because then you see each change introduces either improvement or a decreasement of your indicators. All right, now turning to our number crunching, when we try to calculate our emotion score. We pride ourselves on having a very intuitive and accessible way for our user to understand the emotional data. There's a dashboard with a lot of aggregates, and you can drill down each of these KPIs to really find out what went good and what went wrong in user. So it's a lot of data crunching behind it. And when we started working on this, we thought, okay, let's make our life simpler, just use a JSON field in our database, we can reuse some models, it's easily extendable, and then we can easily maintain it. And with all the test data, it worked quite well. 3-minute test meetings, no problem. But then we encountered real, actual meetings that take longer than 3 minutes, like 30 minutes, and suddenly you could measure the loading time of this view that shows the dashboard in minutes rather than in milliseconds. So this was really something that screwed up our user experience. And yeah, of course, we needed to do something about it, and with profiling, we measured that especially this JSON operation, decoding the JSON file from the database into our code all the time, took a lot of time and was one of the main drivers of the slow loading times. So we needed to refactor it to some dedicated models. So the lesson learned here is kind of, don't be lazy, but that sounds a bit harsh. Sometimes just the easy way is not the optimal one. Of course, it seems that this is like low-hanging fruit, but try to start thinking about what could happen when you encounter real-life data and not just some 1-minute example meeting. But let me contradict myself. Sometimes it's also good to keep your heads up and see what's already available out there. For instance here, I'm sure you can read it and I'm sure you understand this, that this is a correlation analysis from our dashboard. On the left-hand side is the code we came up with from scratch, because of course we wanted to do this so we have the full ownership, full transparency of the code. We wanted to see how every twist and turn works, but at first we had a lot of database calls in this method, and we used a lot of intermediary lists and dictionaries and so forth, and this slowed down our process really, really hard. So we introduced first data frames from Panda that just have one database call to load all the data. That worked very well. And then we thought, okay, maybe there's another way to do this correlation analysis. And we found that some pretty smart people came up with one of the best solutions to do correlation. So of course, we refactored our code to this like one single line. So sometimes it makes sense to have a look around, keep your heads up, and see are there any frameworks available, especially when they are heavily used and you know they're maintained, that it totally makes sense to use them and not produce your own things. Alright, some words about privacy. All this emotion analysis from faces in Zoom calls sounds pretty spooky and invasive, I know it. But we always ask ourselves, is what we do ethical? And we have a red line we don't want to cross. And also we try to do or honor privacy as much as possible. We follow the privacy by design approach. That means that every video that is analyzed is discarded afterwards. Each descriptor image is discarded after the user is happy with the manual merge. When I tell this to companies in sales meetings, they are really, really happy because their data privacy officer agrees with this process. No data on our service, perfect. Just a bunch of numbers assigned to a name. Of course, when I talk to data scientists, they see a lot of wasted potential. No videos, no more opportunities for learning, no more improvements. And of course, we are stuck with our original version. We don't train our models because we don't have the data available. But let me tell you why this is. Especially in situations where you have to show emotions, like in market researches, you need a safe space. When you show emotions, especially sad ones, you feel vulnerable and then you don't want a camera recording you and putting it on the server so that your crying face is there stored in some server space, even if it's in Germany. You don't want it. You want to feel safe so that you can show your emotions. And if the trade-off is between model improvement, maybe a tiny bit, and a safe space for our users, then the case is pretty clear for me. All right, let's have a look at the time. Still 5 minutes left. So we can dig into some actual meetings so you see how we really use our algorithms in the wild. So at first, a bad example. You see here 3 lines. I hope you can see it. The green line in the middle is our customer, and a colleague and myself, we are the black and the blue line. And it's a typical sales meeting. We go tag team on our customers, or on our customer who quickly flatlines. We have a bit more emotions. It's kind of a good cop, bad cop situation. I'm the happy one, my colleague is the bad mood one. Yeah, but our customer, do you see the spikes? There are not many at the beginning and in the end, when you ask some questions. Otherwise, it's a complete flatline. It's not a memorable meeting for him, emotional-wise, because he didn't feel anything. And maybe that's the reason why he's ghosting me and my emails for over 1 month now, because we couldn't get him to show some emotion and to really feel something in this meeting, because only when you have emotions connected with memory, it's really stuck in your head. Let's have a look at another bad example. Here we see another sales pitch of a colleague with a customer, again the green line's a customer, and you see like a mirroring happen. Every time our sales guy goes up, the customer goes down. Worst case scenario. Why does this happen? When we look at the slides connected with each data points, we notice it's a typical sales. Feature rich, what we can do really good, but what does the customer want? She wants solutions. How does it solve her problem? But it wasn't part of the pitch. So of course the expectations diverge and so the emotions diverge. So what can we learn from it? Always ask your customer or your lead or the people you're presenting to upfront, what are their expectations? Either at the start of the meeting or better prior to the meeting. Try to really understand what they want so you don't have this kind of mirroring, because this is even worse than having a flat line, having bad memories that are not really in sync with the customer, with the sales rep. Bad memories in itself aren't sometimes that negative. Because, I mean, you can start with some sad example and then you pull up the customer, but if the customer has bad experiences and a negative mood and you don't, then something is really wrong. Okay, let's have a look at a positive meeting or a good meeting, and I call this the happy gathering because each person, this was a sales rep and a customer in a sales training, both were really in the positive mood. And you see they're almost in parallel. The one goes up, the other follows. And this is like what we call empathy. It's an empathetic meeting. And when we asked the customer afterwards, she was really satisfied with how the meeting went. And one important factor is the end. Look at how both graphs are at almost the limit of the positive scale at the end. And this is the peak end rule. We always remember the last minutes or last seconds of a meeting, and especially when there are positive emotions connected with it, we perceive the full meeting as very positive, even if maybe the start was a bit bumpy. So always try to get the people in a happy mood at the end of a sales pitch, a meeting, a presentation. We don't only need to use our algorithm in retrospective, we could also do it to plan meetings. Look at the chart above. It's a small diagram I have drawn. And here's a happy start with some anecdotes, some memes, some jokes, then the necessary dips so you don't overstrain positive emotions. Too many positive emotions in a meeting are sometimes a bit too pushy, so we have a little dip, and then it's a slow increase in mood to the happy feeling, so in the end everyone leaves the room happy. And that is actually my tactic for my meeting today. And you see below the dry run I did with my wife. And it's quite okay. We have a lot of spikes in the end, so I was really happy with my dry run with her. I also used it to improve my slides prior to this. On the left-hand side, you see an old draft of my slide with the black and white faces. It only scored 25 out of 100 emotional points, so to speak. And the new slide was rather more in the 50 direction, 49. It was quite good. I was satisfied with it, so you've seen it today. All right, some takeaways. I hope each of you got something out of this today. Might it be technical, only use 1/5 of Zoom frames, or don't be lazy, or sometimes be lazy, this contradiction, or you might have learned something about meetings. For me, this experience of coming up with this talk was a nice takeaway as well. I reflected on 1.5 years of development on Mataon, and this is a really big takeaway for me to document our findings here. So yeah, talk to me after the session, the whole day, when you want to see Mataon in action, shoot me an email, connect with me on LinkedIn, and yeah, I think it's spot on.
Next, can I also invite you?
Gladly.
So first question, what is your expectation to this Q&A? Why do you say it's so important?
I hope it's not too difficult questions.
Not too difficult questions. Okay, so you're actively using this to improve your pitches? So is there something where you can say, what has changed your, I don't know, I think you can't speak about sales numbers here, but is there something you could share with us? What did it improve for you?
It's the perception of a meeting. This concept of emotional selling is kind of a buzzword now, and we really started feeling it when we analyzed the emotions in our meetings and on what it really means to have emotions and to really work with emotions in a meeting. So for me, I try to when I draft a talk or a pitch, I try to get more emotions in it. I try to really get something, some content that evokes emotion.
Okay, but in the end, there's not like, oh, now our, I don't know, we sell XYZ more. There's nothing.
We are quite at the start of with our product on the selling phase, so I can't really tell you if there's any positive trend.
Okay. Interesting. So yes, we have our conference app, so you have a Q&A section, so feel free to also add your questions for the Q&A there. I can see we have from the people here two modes. Do you incorporate knowledge from previous frames, or is each frame treated individually?
For us, each frame is treated individually in the analysis, but then when we, for instance, show the graph and do all our KPIs, we have a moving average for the calculation. So you always have like the last, for instance, 50-20 seconds considered into this calculation. So you have like this little drag of emotions.
What was the average time delay of emotion adjustment between one person to another?
Oh, that's a really good question, but it really depends on the people. Mm-hmm. So I can't tell you any average because I haven't really looked into it. But sometimes you see people are really reflective on this. So when they see someone smiling, they instantly go up. And sometimes you see a little lag, just because people need to process this. I mean, everyone knows people that are more emotional in our peer group, and so it's with every meeting.
What about fake smiles? So I could imagine maybe even there's some sarcasm where we would just say, oh yeah, feature XYZ or whatsoever. How do you treat this fake stuff?
And exactly, that is one of the edge cases when someone really puts on a smile and tells you all you say is bullshit. And that is one of the weak spots of our algorithm. So actually this facial action coding and the action units I told you earlier, they could distinguish between different kind of smiles, but we didn't consider it for our algorithm. So what we have now is a situation, of course, when someone says, hey, it's bullshit, but smiles, that we detect this as a positive emotion. We have two ways of handling this. The first one is when we both interact, and now you tell me my pitch was bullshit, your emotion might go up, but mine goes really, really low. So I can see that there is like an odd movement in our emotion graph, and then I can try to dig deeper and figure out what happened. And then the next step would be to consider vocal expressions. What did you say? How did you say it? But that's on our roadmap and not implemented yet.
Okay. But also only if you really show that your emotion goes down, if you are a bit like holds the pain, Harold, right? Like having a yes, thanks for the feedback, then it's really not working.
It depends. I mean, a few micro expressions are really subconsciously. So of course you might have the smile, but then in your eyebrows you do something differently, and then we can at least detect that something is wrong.
Okay, cool. Okay, I would say one last question. Do you analyze the voice as well to foster the emotion classification?
Yeah, unfortunately not yet, but it's a really good idea to get, of course, what was said, which words were used, but also how it was said, this para-verbal communication. This is something really insightful, and we're working on this.
Cool, so thanks a lot for the insights.